look at solving some complex word problems. The sum of the ages of Shaun and Matthew is 29. The sum of the ages of Shaun and Billy is 26. The sum of the ages of Billy and Matthew is 31. Who is the youngest among these three boys? How old is the youngest boy? Here are the three boys: Shaun, Matthew, and Billy. Now, the problem is asking us, which one of these three boys is the youngest? And how old is the youngest boy? So, in order to find that out, we need to know how old each of these boys are. But since we don't know how old they are, let's assume their ages by using a variable. We can assume Shaun's age by using the variable s. We can assume Matthew's age with the variable m. And finally, we can assume Billy's age with the variable b. The problem also tells us the sum of the ages of a group of two boys. So, let's write this out. The sum of the ages of Shaun and Matthew is 29. We can write this as an equation. Remember, we assumed Shaun's age as s and Matthew's age as n. So, as an equation, we can write this as s plus m is equal to 29. Now, let's look at what else we're given. The sum of the ages of Shaun and Billy is 26. We can write that like this, where s is Shaun's age and b is Billy's age. When we add s plus b, we get a sum of 26. Finally, the problem also tells us the sum of Billy and Matthew's age, which is 31. So, we can write this as b plus m is equal to 31, where b is Billy's age and m is Matthew's age. Now, we've written everything out, but we want to find the ages of all three of these boys. And here, we have three different equations. Well, this would be a lot easier to solve if we only had one equation. So, how can we make three equations one simple equation? In order to do that, we can add all three of these equations. So let's do that. Starting with the left side of the equation. There are two s's, two n's, and two b's. So we can write the left side of the equation as 2s plus 2b plus 2n. And on the right side of the equation, we have to add 29 plus 26 plus 31, which is 86. This gives us the equation 2s plus 2b plus 2n is equal to 86. Now, we can divide this entire equation by 2 to make it a little easier to solve. So, if we divide the left side of the entire equation by 2, we would get s plus b plus m. And of course, since we want to divide the entire equation by 2, we would also have to divide 86 by 2, which gives us 43. So, if we divided the entire equation by 2, we would get s plus b plus m is equal to 43. So now, we know the sum of all 3 boys. But how do we find the ages of each of the boys individually? Well, remember, the problem tells us this. It tells us the sum of Shaun and Matthew, Shaun and Billy, and Billy and Matthew. So, we can substitute one of these sums into this equation. For instance, we know the value of s plus b. The value of s plus b is 26. So, instead of writing s plus b, we can simply write 26, like this. 26 plus n is equal to 43. And now, we can solve this to find the value of m, which is Matthew's age. So let's do that. Let's take 26 to the right side of the equation. Here, it is positive. So on this side, it will subtract. 43 minus 26 is 17. So m is equal to 17. Now we know how old Matthew is. Now, we can plug in the value of 17 into any one of these equations that has m. So, let's use this equation. S plus m is 29. And we know m is 17. So let's put 17 into that equation. To find the value of s, we can take positive 17 to the right side of the equation, where it will subtract. So s is equal to 29 minus 17, or s is equal to 12. So now we know how old Shaun is. Shaun is 12 years old. But now, we need to find the age of Billy. So, let's substitute the value of s into one of these equations. We can do that in this equation. S plus b is 26. We know s is equal to 12. So, 12 plus b is 26. Now, let's take 12 to the right side of the equation. Here it is positive, so on this side, it will subtract. B is equal to 26 minus 12, or B is equal to 14. So now we know that Billy is 14 years old. And we know the ages of all three boys. So let's write that out. Clearly, Shaun is the youngest, since he is 12 years old. But just to be sure, let's go back and check our work. To check our work, we can use these three equations that we made earlier. We know the values of s, m, and b. So we can plug those values in to each one of these equations to make sure that we're correct. So let's start with the first one. S plus m is 29. Well, s is 12. And m is 17. So, 12 plus 17, which is 29. Let's check the second equation. S plus b is 26. Well, s is 12. And b is 14. This gives us 12 plus 14, which is 26. And what about the last equation? B plus m is 31. B is 14. And m is 17. So, 14 plus 17 is 31. This proves that our answer is correct. Shaun is the youngest boy, and he is 12 years old. Now, let's look at another example. When I was your age, you were only 4 years old. I will be 79 years old by the time you reach my present age. The father says to his daughter. How old are the father and his daughter? To understand this problem, let's lay this out on a timeline. Here's our timeline. This point on the timeline presents the time now. And here are the daughter and the father. So, how old are they now? Well, this is what the problem is asking us. So, let's assume the daughter and the father's ages by using a variable. We can assume the daughter's age by using the variable D. And let's assume the father's age with the variable F. Now, let's look back at the problem. When I was your age, you were only 4 years old. In other words, when the father was D years old, the daughter was only 4. So let's put this on our timeline. This point represents some time before. So when the father was D years old, the daughter was only 4. Now, let's read the next part of the problem. I will be 79 years old by the time you reach my present age. In other words, when the daughter is F years old, the father will be 79. So let's put this on our timeline as well. This point represents the time some time later. So, when the daughter will be F years old, the father will be 79. So now, we've plotted everything onto our timeline. But this looks a little confusing, since we are using 2 different variables, D and F. So, how can we only use one variable to make this a little easier to understand and solve? Well, let's think about it. Remember, the difference between the father's age and the daughter's age will always be the same. So, if we find the difference between their ages, we can subtract that from the father's age to get the daughter's age. So let's do that. And to do that, we can subtract the father's age minus the daughter's age, which would be 79 minus F. The difference would look like this. Well, now that we have the difference in their ages, we can subtract it from the father's age. Because remember, we do not want to have 2 different variables. So, to get rid of the variable D, we can subtract the father's age now minus the difference between the two ages. So let's do that. F minus 79 minus F. Remember, the difference between the two ages always stays the same. So let's open the parentheses and distribute -1 inside the parentheses. -1 times 79, which is -79, and -1 times -f, which is +f. This gives us the expression f minus 79 plus f. Now we can combine like terms. F plus f is 2f minus 79. So this gives us the daughter's age now. So instead of D, we can write 2f minus 79. Now we have everything using the same variable, the variable f. And we want to find the daughter and the father's ages now. So how can we do that? Well, to do that, we can set up a single variable equation. And we can set this equation up by using the difference in their ages. Remember what I told you earlier. The difference between the father and the daughter's ages will always be the same. So, if we find the difference between their ages, we can simply make them equal and solve the equation. So, let's do that. We already know the difference in their ages sometime later. 79 minus f. 79 is the father's age, and f was the daughter's age. So now, let's find the difference in their ages some time before. So, we can do the father's age minus the daughter's age, which we could write like this. 2f minus 79 minus 4. And now, we can make these two differences equal to set up our equation. Now, let's open the parentheses. Now, let's simplify the left side of the equation. -79 minus 4 is -83. (2f minus 83 is equal to 79 minus f. So now, let's bring the variables to one side and take the constants to the other side. So, we can bring -f to this side of the equation, where it will become +f. And let's take negative 83 to the right side of the equation, where it will become positive 83. This gives us 2f plus f is equal to 79 plus 83. So let's simplify both sides of the equation. 2f plus f is 3f, which is equal to 79 plus 83, which is 162. Now, let's take 3 to this side of the equation. Here, 3 is multiplying. So on this side, it will divide. F is 162 over 3, or F is equal to 54. So now we know the value of F. Let's put that on our timeline. But now we need to find the daughter's age, which we assume to be 2f minus 79. And we know that f is equal to 54. So let's plug in the value of f. 2 times 54 minus 79. 2 times 54 is 108. Minus 79 is 29. So we know the value of 2f minus 79. Let's put this on our timeline as well. Now we know that the daughter is 29 years old and that the father is 54 years old. But just to be sure, let's check our work. In order to check our work, we can find the difference between the daughter and the father's ages during each one of these times. So let's do that. Starting with the difference in their ages sometime later. We can find the difference by doing the father's age minus the daughter's age. So 79 minus 54, which is 25. Now what about their ages now? We can find the difference by doing 54 minus 29, which is also 25. And finally, for the difference in their ages sometime before, which we can find through the expression 29 minus 4, which is also equal to 25. Since the differences in their ages are always the same, we know that our answer is correct. The daughter is 29 years old, and the father is 54 years old.